In the second example, we're being asked to draw a circuit with two light bulbs, this time each being controlled individually by their own switch without affecting the other bulb. So if I open the switch for one of the bulbs, it should go off, but its companion should remain on. Now, this is a very special type of circuit, which we will be looking at down the road, but I'm going to get across to you the basic thought process. So as always, we're going to start with a battery. We're going to add some wire. Now, anytime you see individually, unaffecting the other element, something along those lines, that's a dead giveaway that whatever you're referring to, a light bulb, a regular resistor, it has to be on its own pathway. So if I want to ensure that one thing does not affect another, I cannot put them on the same pathway. So I'll add one pathway with the first light bulb, and then I'll add a second pathway over here. Now, because I split those pathways, what happens on one will not affect the other. So there are my two elements, my two light bulbs. I will close that circuit, and you'll notice now I have two distinctly different pathways. I cannot put my switch where that red circle indicates, because if I cut off current to that section, that one switch will control both light bulbs, and that is not the requirement we are looking for. So we understand we can't place it there. But if I place them in this location or in these locations, you'll notice when I open one switch, one light bulb remains on, but the other shuts off, and vice versa. Therefore, knowing that each of these switches will individually control, my final diagram should look like what you see here. And no matter which of these switches is turned on, only one of these light bulbs will be deactivated. Yes, I can turn them both off by hitting both switches, but by isolating each switch to its own specific pathway, that will only affect the one light bulb without affecting the other.